Hello guys, and welcome back to another Kubernetes video. So today we'll be talking about replica sets, deployments, and namespaces. Let's get into it. First of all, we're not going to jump straight into replica sets. We're going to first start with pods. So to summarize and to recap, pods are a group of one or more containers with shared network and storage resources. Let's have a look at the YAML now. We have kind, image, and container port. So for every Kubernetes YAML file, we'll have this kind field. In this case, we're obviously specifying a pod, so it's a pod, but just understand that it could be a deployment, it could be a replica set, it could be any other Kubernetes object. Down here, we have specified the container and the image. We're using Nginx, and the version is here. And the container port is a port that is opened for this specific container, which allows communications with other pods. One more thing that has to be mentioned at this point is that Kubernetes is synonymous with self-healing. However, if we deploy pods on their own, this self-healing isn't applicable. Pods are an ephemeral resource, and if you deploy a pod with no other connected or related resources, then that pod may be deployed to a node, that node may go down, and when that node goes down, that pod is deleted forever and it won't be seen again. This is where a replica set comes in. So a replica set is a type of Kubernetes controller. You may remember from my prior video about the control plane that there are multiple different types of Kubernetes controller. Well, the replica set is the controller that ensures that a certain number of pods are online in the cluster at all times. It ensures that a specified number of pods are running. It facilitates load balancing and scaling. So if you're running multiple pods for a single application, the traffic for that application will be spread out amongst those pods. This is how it facilitates load balancing. We also have to work in conjunction with other Kubernetes objects like services in order to facilitate that load balancing, but those two components in conjunction will allow traffic to be balanced across multiple containers. Replica sets are also scalable, which means that if the customer base for a particular application that we're using grows and the load grows, then we can scale out and add more pods at any time that we need. We can also scale in if we need to as well. And finally, Replica Set is the new version of Replication Controller. Replication Controller is a similar purpose but slightly different in how the YAML is specified and what exactly it does. Just know that Replica Set is the standard in today's Kubernetes environment. So what does the replica set YAML look like? First of all, let's look at the bottom section. Everything under template, including spec, that is a pod definition. The replicas determines how many of those pods we're going to deploy. The selector includes pods in the replica set that match. So in this case, we have a condition to match the labels tier front end, so it's just a single label in this case. But if we look down at the template, we see that we have a label tier front end. That is how we connect the pod with the replica set. A replica set can include pods created before the replica set existed. So let's say we define this file and we run it using kubectl to apply it to the cluster. There are two potential scenarios that may happen here. We may create 3 brand new pods with this specification that we have defined under template, or there may already be existing pods in the cluster that have the label tier front end, and the selector identifies those pods and incorporates them into this replica set. Finally, replica set is a process. It is not a cannot be thought of as a physical entity in the cluster. It's just a process that runs and monitors the pods. Replica set commands. So if we want to scale our replica set, a couple of options. The first one, kubectl scale. Here we specify the number of replicas. Replica set is a type of Kubernetes object, and myapp-replica set is simply the name of the replica set. Kubectl replace. In this case, what we would do is we would modify the YAML file and specify the new number of replicas that we want, and then we can just run kubectl replace and specify that YAML file that we have used. Now, at this point, you should probably understand that replica set is a parent object of pods, and likewise, deployments are a parent object of replica sets. So why you think a replica set does provide some nice functionality, why would we need another parent object for a replica set? The reason is because we want to be able to intelligently control the life cycle of our application. If we have just deployed a replica set, if we want to switch to a new version of our application, that will have to be done all at once, and there's no way of intelligently rolling out the application without taking major risk in terms of introducing bugs or potential outages. However, the deployment will solve this problem because it would allow us to do rolling updates where we have one version of a replica set, and we create a new version of a replica set, and essentially the pods active in the cluster are slowly migrated from V1 to V2. With this, it allows us to detect if there are any errors in our new version of the application. If there are, we can simply roll back, and if there are not, we will run through to completion where we have our new version of a replica set and all of the child pods. Then this old version will be deleted if we're happy with how the rollout went. So deployment allows us to perform rolling updates on application versions, as I mentioned in the last slide, and it allows us to roll back these changes. Now, what does the deployment YAML actually look like if we wanted to define deployment? It's actually essentially the same as replica set, with the only difference being deployment kind. Deployments automatically create replica sets. So you can see in this little screenshot I attached here, I ran this command on a namespace that I created, ingress namespace, and that contained a single deployment. So the deployment was created, and that in turn created a replica set, and the replica set in turn created 3 child pods. So a nice thing with deployments is you just have to specify one child, and all of these resources are created automatically. Namespaces. So at this point we're starting to get kind of a little understanding of how our Kubernetes cluster might look and the ecosystem. So it's important to think about now, how do we divide resources in our cluster, and that is where namespaces come in. Firstly, namespaces provide a logical separation between cluster resources. So let's say you have a cluster, you're a small company and you have 2 or 3 applications. In that case, if one cluster is enough for those applications, you may define multiple namespaces, and you'll essentially have one namespace for each application. The benefit of this, apart from the logical separation, it allows us to control permissions between namespaces. So for example, if we have one team of developers working on a particular application, we may not want them to be able to edit and delete resources in the namespace of another team that's working on a different application. So that is one of the ways we can leverage namespaces. We can also leverage namespaces to apply resource quotas. So let's say we have a particular application that should only have at max ever 1/4 of the cluster's resources. Finally, when we're referencing different entities within our Kubernetes cluster, the fact that we are within the same namespace as that entity or not defines how we can actually reference that particular entity. So let's say we have a service named DB service in our current namespace and we want to talk to that, we can just say DB service. But if that service is in a different namespace to us, then we have to do dbservice.namespace.svc.cluster.local. So, you know, we know here that's the name of the service, that's the namespace that we're going to use. SVC just means service, so that's a type of Kubernetes object that we'll go into in the next video. And then cluster.local is the default DNS, default cluster domain name. Finally, let's have a quick look at a couple of commands for namespaces. If we want to get all the namespaces in a cluster, kubectl get namespaces. If we want to get the pods in a particular namespace, kubectl get pods-n namespace. And on that one, if you do not specify the namespace that you want to get the pods from, you will get the pods in the default namespace. So maybe the case if you're just doing a bit of local development, or you don't have a massive amount of resources in your cluster at the moment. You might have all of your resources deployed to the default namespace, but if you want to, if you're already working with namespaces and you create a pod and then you go kubectl get pods and it doesn't come up, that's because you forgot to reference a namespace. So it's just something to keep in mind. So this final command essentially allows us to set a default namespace. So let's say our manager has told us that we're going to be working on a specific project for the next month, and we know all of the resources for that project are going to be within this namespace. We can run this nice little command here, and what that does is it means that we no longer have to specify this namespace. We can just set the kubectl context, and this little subcommand here gets the current context, and we just append the namespace that is desired at the end, and that will allow us to go ahead and reference resources within our namespace without specifying that namespace. And that is everything for this video. I really appreciate you watching. If you did, please give it a like, and if you have any questions, don't hesitate to leave a comment. Thank you very much. I'll see you next time.